Paul, do you have a few more comments to make about the fuel saving for truck sale devices? The boat tail, the trailer skirts, and the gap fairing.
Okay, so the boat tail on a 53-foot trailer lowers the wind average drag by 9% and the fuel by 4.5%. The low-riding main skirt lowers drag by 12% and fuel by 6%. We can extend the skirt coverage by taking advantage of our safety rail concept with fold-up segments, panel segments, covering the wheel bogie domain. And if those are added, then you get 4% more fuel for a total of 10 realistically possible on the full skirt treatment. The gap gap fairing impact, depends on the gap that exists between the tractor and trailer. How big a gap is being run on that rig. So if it's, let's just say, an average 30-inch gap or something sort of typical, not, an ordinary gap you'd have about 3% fuel available to recover there. So all told, if you took it all together, you have 3 plus 10 plus 4.5. That's possible. That's realistic. We can do that.
Paul, you were talking about the fuel savings on a 53-foot trailer that had a truck sale boat tail on it. What about the fuel savings on a straight truck? What would they be like with a truck sale boat tail installed on it?
So the boat tail effect is affected by the length of the vehicle, because the air accelerates and decelerates over a shorter distance, and does so a greater acceleration and a greater deceleration. So the boat tail impact is larger on a short vehicle, on a straight truck, in the range of 10%. So even though a straight truck would not travel the same distances as a long-haul trailer, if it did half those miles and save twice as much per mile, then it's still a considerable amount of energy saved.